Alright, let's take a look at a power supply. So this is actually a little Raspberry Pi kit kind of thing. What I liked about this is it has a switch on the cord, so the Pi can be turned on and off, which can be rather handy when you're working on the bench with one. Let's see, this wire here is marked as a 20 gauge. Our power supply, North PATA. Looks like a circuit board. Well, anyway, this one has a USB jack on the side. I don't feel any screws. Oh, this one may not yield its secrets voluntarily. Comes with a little Pi case. Ooh. North. So it doesn't clip together. Excuse me. Comes with a heat sink for your Pi, a little bitty screwdriver to put the tiny weeny screws in. Just basic case. I don't see anything really wrong with it. Place for the USB, micro USB to plug in. Yeah. Place for your ribbon cable to come out the side. And your Ethernet, your USB, and so on. Here. So, looks like an okay case. I don't see any rubber feet for it, but that's not a big deal. So, put it all back here till I am ready to do something with those Pis I have stacked up. I get more ideas than I have time. So let's set that aside. So, yeah, I don't think this, like I said, this was not going to yield its secrets voluntarily. Let's just take a look and see if yeah, I believe this has been either sonically welded or solvent. Well then, this really requires some undue force. Alright, we'll come back and we'll do that in a moment. Let's see how it performs before I inadvertently break it. We'll plug it in. We'll plug it into the outlet. Now it doesn't have an indicator on it, but well, indicators are just nice. So we're going to plug this in to the port. Turn it on. Alright, I have 5 volt, 5 point, get it all the way to 0. 5.08. Start turning the current up. Ooh, we're down to 4.98 by half an amp. 1 amp, we're at 4.92. 2 amps, we're at 4.86. 3 amps, we're at 4.7. That was it. That's all she offered. It'll be interesting to see what's in here. This is supposed to be, oh, no, what? No. 5 volts, 2.5 amps. We're still within reason. Again, another range of 100 to 240. but this will require a little bit more.
Alright, I've cracked her open. And see what we can see here. Alright. It's in there pretty good. There we go. There we go. Now it's out. Alright, so first thing I notice, I've got a plastic shield to cover up the two mains connections. We've got a typical bridge rectifier, resistors and capacitors and everything in a switch mode chip. Tried to look at the switch mode up, can't find a data sheet on it. We got a common mode inductor there. Our input, our filtering for input. Here's the filter cap for the power supply for the switch mode chip. In fact, if this guy were to stop working, that would be my first suspect. Capacitor for our mains filtering. This is our coupling between our low voltage side and our main side. This guy here is the appropriate guy. He's got all the wonderful symbols he's supposed to have. Don't see an opto isolator in this. I'm thinking they're using a winding back from using a separate winding on the transformer to pick up the feedback. So I'm thinking, yeah, this must be the high-speed diode for the power supply. At least it goes to the 1000 microfarad 10 volt cap. Let's see what else we got here. So yeah, really not a lot to see. So notice there's no gaps, increased creepage or anything. They do have some crude surge suppression here. Basically, if there's a surge, it jumps the gap. So, yeah. That's basically it. Not a whole lot to it. Oh. Where's the fuse? There's no fuse. Huh. Yeah, there is no fuse. So I guess these are fairly heavy traces too. Not sure I'm comfortable with that. I guess if something were to go wrong, blow a winding out in the inductor. Alright, well that's it. Put her back together. There you go. There we go. Alright, back together. Alright, that's pretty good. Alright, let's plug it in there. Zoom on back a bit. Get more of the bench. Alright. I've already pulled the tape off this one. This one glued back together rather well. Since this one is a USB output, we're going to plug
this in. Tells us what the output of our is. We got 5.09. Then I'll plug this cable in. Then I can plug this into here. Alright, so this is the one that has a switch, so we need to make sure it's on. And get this so we can see it together. Alright. Little bit of a deviation between that. Gives you an idea how many amps this thing's pulling. It's a 0.01, so this is 10 milliamps, which is not bad. So at the end of the cable, we've got 4.8985 volts at around an amp. Let's see if I can get to 2 amps. At 2 amps. We're at 4.8 at the end of this cable. But notice the power supply is 5.17, 5.17. It's not surprising. We're getting a considerable voltage drop across this cable. So we're at 2 amps. There we go, a little about 2.5, 4.76. 2.68. I was wondering when it was going to kick in. It was getting kind of warm to hold. Uh-huh. 4.68. That's 3 amps here. 4.68. Alright, 3 amps. Notice that the output of the power supply is still 5.24 volts. So the power supply regulates pretty well. So we're at this point we got we'll say that 0.4 volts we're losing here. Well, 0.4 plus the 0.26 is 0.66. We're losing more than half a volt. Oh, which that's obvious. And there she goes. Power supply just went into fold back. So this is where it drops the voltage to keep the current from going up. So up here works around 3.5. Yeah. We'll take the lid off the power supply. Alright. So let's take a look. This is, and this was rated for 2.5 amps. And this does great. This will do is a great power source. But yeah, the cable unfortunately is a bit lossy. I do like the switch though.
I believe this is 20 gauge wire according to the markings on the wire. Well, anyway, this did quite great. Not too thrilled with the cable, but I guess substitute a shorter cable and a better cable on this and it'll do just fine. Voltage holds up quite well. And it's probably the case for a lot of the other power supplies that I've looked at that have the cable. Power supply is probably holding regulation pretty well, and it's the voltage drop we're getting across the cable that's bringing our voltage down quickly.